Now we're going to see why we use logarithms, because I've got some applications here that contain the unknown in the exponent, and the only algebraically correct way to free it out is by using logarithms. In the first problem, the number n of E. coli bacteria in millions per milliliter after t minutes can be modeled by this function. Determine symbolically, which means find it by hand, the elapsed time required for the concentration of bacteria to reach 25 million per milliliter. So we need to find the time, which is in the unknown. The 25 million is the number of bacteria. So I've got 25 is equal to 0.5 e to the 0.014 t. Now what we learned a little bit earlier is I've got to get my base raised to the unknown exponent isolated. So if you'll divide 25 by 0.5, I'll do it to the side. I come up with 50. You need to see if that's true. Once that base is isolated, now I'm going to take natural log of both sides. One reason is that my numerical base on this side is an e, and the other reason is it doesn't take me so long to write it. We learned in the prior video that whenever my base of my logarithm is equal to the base of the number, that equals the exponent, which is nice because we're almost done. Only other thing I've got to do here is divide both sides by 0.014. So take natural log of 50, divide by 0.014. So I've got t is equal to 279.43. The time frame was minutes. While I have it in my calculator, I'm going to divide by 60. So it looks like about 4.7 hours. This E. coli will get to 25 million per milliliter. In the next problem, estimate the time for p dollars to double. If p is equal to 1,000, your interest rate's 8.5% compounded continuously. Well, the one thing you need to know here is which compounding formula, and it's the continuous. Remember, I call that the shampoo formula. My investment was 1,000 and I want it to double. Interest rate has got to be in decimal. Sort of looks like the bacteria a little bit earlier. Now on this, they really do not have to tell you what the investment is, because I have to, again like before, isolate my base to the unknown. And if I divide both sides by 1,000, I end up with that. So if they ask you to estimate the time for p dollars to double, compounded continuously, then it's always going to look like this. 2 equals e to the whatever the interest rate is. If they asked you to triple, it'd be a 3 there. So let me take natural log of both sides. So natural log of 2 is equal to my exponent. Divide both sides by 0.085, so natural log of 2 divided by 0.085. I came up with about 8.2 years for the $1,000 at that interest rate, compounded continuously, to get to 2,000. Now the next one, a little bit different. A $2,750 investment grows to $4,385 in 9 years, compounded continuously. Find the interest rate rounded to the nearest percent. Alright, so again, it's compounded continuously. So let me get my formula. Put the appropriate values in the correct place. So instead of looking for time here, we're looking for interest rate. And like in the prior problems, I'm going to divide both sides by 2750. It's not a nice fraction. It's actually not a nice decimal, but I do not want to round. I'm going to take natural log of both sides. And now we're going to divide by 9. So let me bring my calculator over for this one. So natural log 4300.85 divided by 2750. And that in turn is going to be divided by 9. So round to the nearest percent. So looks like that would be what, 5%? So R would equal 5%. So that's it for this video. Thank you.